Hello.
Hello. Yeah, Mr. James, welcome.
Thank you very much.
Now, this is the secretary, Omonova Daniel.
Okay.
Now you want to test the screen.
Okay, let me try that.
Okay, sir. Okay, good. I can see it. So maybe you just leave this on the screen. When you are ready, then since
Okay,
that is the title page.
Yeah, that's the title page, but I'm actually thinking of using the. Okay, let me. All right. Sorry.
Hello, sir. Well done. Hello, Mr. James.
Yeah, good day.
Well done.
Thank you.
Mr. Monova, I greet you, sir.
Welcome, President.
Well done. Has he shared his slide?
Yeah, yes. He has done that.
He has tried it, okay.
Yeah.
Okay. Is Mr. Ekan on the line? Ekan is not in the house yet.
Not yet.
Okay. Hello, Secretary. Please let me know when Mr. Okano comes in. He's about signing in.
Okay.
Jimmy, mommy says you got it.
Hello, Secretary. I think we should start.
Better.
Good day, everyone. Welcome to our knowledge sharing series 3 for the month. This month, as we have said, is the oil and gas section, and we've had a lot of presenters who had shared their wealth of experience. So today, we are going to be introducing our first presenter. We have 2 presenters in the house today. Today, we are going to be introducing the first one, who is going to be taking us on this first series, Mr. FADIARO James. We introduce to you Mr. FADIARO James as a veteran HSC engineer, a trainer, a coordinator, and a supervisor with practical HSC experience in drain, construction, civil, electrical, chemical, drilling, and currently in the oil and gas production industry, and a cumulative of 20 years practice. He studied industrial safety engineering from the Petroleum Training Institute and has also amassed several trainings and certifications in the field of occupational health and safety, in addition to the professional proficiency. He has had an hands-on involvement in several HSC processes, including HAZOP, HSC management of project, SIMROPS, etc., with practical involvements in design, education, and communication of several projects that were not only successful, but with good HSC performances. I welcome Mr. James FADIARO, our presenter. Thank you very much, sir, for volunteering.
You're welcome. Thank you very much. Glad to be here with us today, and we'll be looking at developing adequate barriers for safe operations. Mr. Secretary, I don't know, do we have any pre-training protocols before I start, or should I just go on?
No, just go on. It has been established by the president. ASSP will just recognize the coordinator is in now. If he wants to just share or some words with us. Mr. Ekam. Mr. Ekam, do you have anything to share before the presenter?
Yeah, well, good evening all. We're already behind time. Whatever I'll say in the course of the program. Well, all I can tell the participants that safety today is encompassing. That let us don't forget, let us be open-minded, not just a matter of oil and gas. That barrier for safety operations, adequate barriers is another interesting thing. If it is what I believe it is, the barrier process will be of beneficial to in every other aspect of our human endeavor if we just make a reverse of it. So I wish everybody good listening, and the appropriate time I'll make my contributions, and if any remarks in the on the training so far. My sincere apologies for coming in late. So it was due to
no problem,
technical issues.
You're welcome, sir. You're welcome. Also, presenter, over to you, sir.
Okay, thank you very much, Mr. President. So without further ado, I know that there's another training after mine, so I will try as much as possible to save time. At the end of this presentation, we expect that everybody will understand what safety means in operations. When they were reading my bio, they were explaining that I've been involved in several projects, and one of the hallmarks of such experiences when you have been able to adequately be a part of designing, commissioning, and execution of projects, and yet those projects had very good HSE performances. They did not have fatalities. We didn't even have LTIs in most of these projects I'm talking about, and many of them engineering projects involved. We just recently commissioned the construction of two 20,000 barrels, and we just put crude in them just last week. This is one of the projects we did a few years ago. Had trucking and barging operations starting from the scratch to execution of that project. We did not have a single accident. So I believe that by the time we share this presentation today, some of us will pick up the practical ideas that help in executing such projects without any HSE issue. So understand why barriers are needed, areas of application, categories of barriers, and why barriers fail, and remedies to those failures.
Like we lost him.
Yes.
Let's just be patient
give
for
him
him.
some minutes.
Hey, how are you?
Hello.
Yeah, sorry, we lost you. So you can just, I think you're in the second slide. So you can just go back to it.
Yes. Okay, let me see. Okay, I think I went through the learning outcomes that at the end of this training, we should know what barriers are, what safety means in operation, why barriers are needed, areas of application, categories of barriers, and why barriers fail, and their remedies. All right, in most operations, you find out that it seems as if safety and operations are invariants. I've heard a lot of safety professionals complain that operators don't like to follow safety rules. I've equally heard a lot of operators complain that safety rules seem to be a form of hindrance to operations. In the real sense, and operations should actually work in a symbiotic manner. They should complement one another. A safe operation should actually be a more efficient operation. And when we understand how barriers play their roles in our operations, we may be best put in a professional stand to make our safety more relevant in the operations. Now, what do we do as HSC people? What we do basically is to understand what hazards and risks are and prevent their occurrences. In summary of all we do as HSC practitioners, this is just it. And this slide is just to review the definitions. As we all know, hazards happen to be anything, including processes, that have the potential to cause harm to any person, equipment, or environment. Now, this definition shows that almost anything can constitute a hazard. Risk, in the other hand, is the possibility or the probability of releasing that hazard in a particular, sorry, 1 minute. In a particular situation and the consequence of such a release. To make it a bit clearer, water on the ground can cause slips and fall, so it's a hazard. However, if that water is at the corner of an office, the risk there is less than if that water on the ground is at the staircase. You will all agree with me. So hazards and risk are not the same. Most of the time we concentrate on the risk. A particular hazard can have varying risk at any time. So what do we use to prevent such release or minimize the impact of such release? Like I said, this is the sum total of what we do as HSC practitioners, whether you are a trainer in HSC, whether you are a safety officer, whether you are the one that is drafting policies or you're the manager or the supervisor. The sum total of what you're trying to do is to prevent hazards from being released or minimize the impact of such release. We do this by creating barriers. All these here are examples of barriers that are usually in operations. These barriers are applied both as preventive and corrective situations. If you look at this bow tie model, it explains that when the threat is released or the hazard is released, in order to avoid it from becoming a top event or a major accident, you need to put some set of barriers. However, if these barriers fail and you do have an incident, you also need to be able to minimize the impact. Practical examples. We built 4 protections for work at height to prevent falls from happening. But we also put fall preventive, or we put fall arrestor gadgets in place in case somebody does fall, they do not actually hit the ground. So if your barriers for prevention is adequate, it's likely you do not have a major event. And however, if you do have a major event, if your barrier for corrective or mitigating the incident is adequate, the consequences will be minimal. So you need barriers in these two areas. You need barriers in preventive and in mitigating. I hope we understand. Now, barriers, as good as they sound, unfortunately, barriers are not perfect. There is no single barrier that is 100% proof for several reasons. So most times we do not rely on a single barrier to prevent an accident from happening. Many times we have to combine barriers to form layers of protection for a particular hazard or a particular operation. Now, for each of these barriers that we are putting in place, they should be able to operate independently of one another. No barrier should be dependent on another barrier, because that means that if one barrier fails, the other barrier is no longer useful. They should be able to operate independently, and they should be able to also work together in harmony to create a layer of protection. Now, in operations, we can divide barriers into three categories. There are plant barriers, there are process barriers, and there are people barriers. The plant barriers, they are also called safety and environmental critical elements. These are the barriers that we engineer into our plants. We create these engineering barriers along with the design of the plant to protect incidents from happening. Examples of such barriers are fire and gas systems, our emergency shutdown valves, temporary refuge, etc. Keep in mind, like I said earlier on, you need to be thinking in terms of preventive and mitigating. So barriers should be available for you to prevent top events from occurring or to minimize the impact of such top events, depending on your risk assessment anyway. So for process barriers, there are processes that we work into our operations to minimize the risk of a top event, such as our maintenance, operational procedures or SOPs, safety supervision, risk assessment, hazard, SIMOPS designs, toolbox talk, UAUC reporting, audits, inspections, etc. All these are process barriers that are in place to minimize the release of top events or to minimize the, to prevent them from occurring. Then lastly, we said we have the categories of people. This invariably means competent people. Having competent people in our process is a major barrier. One of the things that weakens the effectiveness of barriers is actually people, human error, human interface, human involvement in operation. So we need competent people. When we talk of competence, we mean people who are knowledgeable, educated, trained for the job they're doing, they are skilled, they have experience, and then they have the right behavior. That's where safety culture comes in. If we recall the last knowledge sharing that we had, we discussed about safety culture, developing safety cultures in our organizations. So this makes up competence in people. And if we have competent people, it forms a major barrier to prevent the release of top events or minimize them. Most of the time, we have emergency shutdown systems. If people are not knowledgeable or trained to activate those ESDs, it may more or less be useless. So competence matters. So why do barriers fail? I mentioned earlier that no barrier is 100% efficient or foolproof. We have vulnerable points in every barrier. This is why we have that, what we call the cheese principle, the Swiss cheese principle. It is believed that in every barrier, there are vulnerabilities, which can be referred to as holes. The hazards can pass through these vulnerable areas and hence form a top event. That is the reason why we usually need to have layers. When we have layers of efficient barriers in place, the possibility of having the holes aligned is minimized, and therefore we can have safe operations. It still does not mean that our barriers are foolproof or that they are always 100% efficient. Now, these are the major failure areas. One is absence. The barrier that is required is missing or removed. Of course, it's no longer effective. How do you identify the right barrier to put? It's basically through your risk assessment. Now, many times people do not carry out risk assessment properly. It is sad every time when I see in organizations or in processes where people take risk assessment as a form of paperwork or just tick the box. A risk assessment properly done will help you to identify what are your major risks. What are the major areas where you can have accidents? Sometimes the risk involved in a job may not be directly associated with the job to be carried out. It may actually be because of the environment in which that job will be carried out. For instance, we all know that we cannot weld in a hazardous area, whether it's a zone 0, a zone 1, or a zone 2, unless we put some other barriers in place. So when you have done your risk assessment, when you've identified the risk involved, and you have seen the barriers that are in place, and you've done your assessment to know if further barriers are required for you to know whether your risk has been pushed down to as low as reasonably practicable for you to carry out that operation. If not, you may even put barriers, but none of the barriers are essential. You may not be putting the adequate barriers or the right barriers in place. That is the second area of failure of barriers, inadequacy. If the barrier you put is not the right one or is not sufficient, your barriers will not be effective. You will still have the release of accident. For instance, you have an ambulance so that you can medevac a health emergency in order to minimize the possibility of somebody dying or the situation getting worse. But the ambulance is not working, cannot start. At the time you need it, that barrier will have failed you. That is, it is not adequate. How do you ensure the adequacy of your barriers? Is regular reviews. Review your processes from time to time to ensure that the barriers you have in place are still relevant and they are still adequate. Sometimes your processes have improved or increased in, maybe you have increased facilities in your process, or you have brought in new people, or you have added more work to some people, and therefore there are now risk gaps that you have not identified. If you're not doing your regular reviews and you just go on as normal, your barriers that were initially efficient may no longer be efficient. Inefficiency of barriers can also be caused by inadequate performance of those barriers if they're not functioning properly. I have a gas detector that is not calibrated. It may be giving me wrong reading. For this, you need to ensure that you carry out both preventive and corrective maintenance regularly and adequately. Preventive maintenance correct. I think I've been muted. Okay,
I'm here,
back. All right. Corrective maintenance are needed when issues are spotted with these barriers. If somebody complains that, oh, there's a pin missing on this fire extinguisher, you should carry out corrective maintenance immediately, regularly and adequately. Then lastly, inherent vulnerability of barriers becomes very important. Like I said, no barrier is 100% efficient. There are always loopholes. There are always areas where things may not always be perfect. There's an inherent ability for it to fail. To minimize this, in addition to having layers of barriers, you need to do continuous monitoring. That is one of the things that necessitated the need for safety officers on locations. By doing their walkthrough on a daily basis, checking and inspecting the work environment, they can look at the barriers in place, whether they are still efficient, whether they are still adequate. Supervision is also key in continuous monitoring. Almost 90% of all incidents are due to poor supervision. Almost 90%. And that is why it is important that we put these areas into consideration. The cumulative effect of this Swiss cheese model is that when there are latent failures that we don't see immediately creeping into the system, they create holes in this barrier. Majority of the time, because there has not been any incident, we leave them there. I mean, people have been filling permit to work, carrying out jobs without actually having any incident, but we don't know that people are not doing proper risk checks or risk assessment before signing permit to work. We think we have a permit to work system in place, but that permit to work system is no longer efficient. Now, those latent failures remain creeping, festered into the system and start breaking down other barriers until one day somebody commits an unsafe act or unsafe condition, which is the active failure that leads to an incident or an injury or a loss, and then boom, we have a top event. Most times we think that it is that unsafe act or that active failure that created the problem, but the problem has been lingering in the system all this while. But I can promise you that if you practice these 4 processes to adequate risk assessment, the regular reviews of your barriers or your processes, to preventive and corrective maintenance on your preventive and corrective maintenance on your barriers, and do continuous monitoring on your processes, you are most likely not going to have any top event or any major accident on your location. I don't know if we have any questions. Like I said, I tried to make it as brief as possible because we we have another training and time is fast spent, so that we can have time to discuss. Do we have any question?
Thank you very much, presenter. Thank you. We appreciate your volunteering and the detailed explanation. So we'll hand over to the coordinator to coordinate.
Dan, hello. Please,
Yes.
we like in every other training that we're having, before we go into the questions and answer, we need to thank the presenter for a job well done. Please, can you mute? At least we can give him a hand of applause, or you could sign a chat to him telling him well done, because he has made it as simple and related to virtually everything that we do, even outside oil and gas. So very, very thank you for a wonderful presentation.
Thank you, sir.
Thank you very much. Thank you.
Before we go into the question and answer, as part of our thank you to you, if your virtual certificate is ready, I think we should give it to him about now, because barrier model is going to have a lot of questions, a lot of explanation, so that at any time we can always drop off for the second presenter. Sec, do we have his certificate handy for him?
Yes,
or
let me
done at the end of both sessions?
project it for your presentation.
Good evening, the coordinator. Someone in the group has a contribution to make.
When we get to that place, everybody is going to make contribution. Please, we just want to thank our presenter for today and present him his certificate. Then we'll go back to conclude his session. We are going to take individual contributions as well as question and answer. Please, thank you for the reminder of bringing that to my notice.
Thank you very much, coordinator. This is a very wonderful certificate.
Mr. President, please, who is doing this presentation to him for us today?
The secretary.
Okay.
The secretary.
Dan, the floor is all yours.
Okay, thank you. On behalf of the ESCOs of American Society of Safety Professional Nigerian Chapter, I have the privilege of presenting the certificate to you, Mr. FADIARO James ADEKUNLE, volunteering in the ASSP Nigerian Chapter as a speaker on developing adequate barriers for safe operation during the Knowledge Sharing Series 3 of July 25th, 2020. So we appreciate you. We are going to email this to you after the knowledge training session. Thank you very much.
Thank you very much. I'm honored. Thank you.
Okay. Dan, thank you. Thank you for that wonderful presentation. We are about going into the question and answer and contribution session. Please, like in every other training that we normally do, you raise your hand and the secretary or the co-host, Dan, will help admit us in one after the other. But before we go into that session, just like I had told several other participants, this is just the beginning to bring in more awareness what you can gain from being a member of ASSP Nigeria and ASSP Global. With learning sessions like this, you're able to meet participants. This is part of networking. I encourage you, the people you can identify, meet them post after the training, interact and ask more questions. And in the upcoming days after this, the oil and gas will still be having activities where we'll take one-on-one, where we'll take questions or interaction within ourselves and share maybe with the global link. But before we go into before we go into the question and answer, please, I just need 5 minutes to give you a recap. What our presenter today has told us that before any major hazard, you have equipment, you have process, and you have people before something serious happens. And it's the same way, the other way around, that something will not just go wrong if we do not have a failure somewhere. So as you contribute, have that in the back of your mind, that much of these things lies with human beings, like we have started from the past two sessions that we had. It is human. Machines can fail, equipment can fail. The last barrier either way is human being in terms of hazard and something going wrong. And the other way around, if equipment should fail, if a process should fail, who is there as a last resort? It remains human being. So it is imperative that take your training seriously, update yourself on current practices, process. We can speak more after this, but let us leave it at that level for now, that human beings, that let us don't keep it just on equipment and process, that we too have a role, getting adequate training, being aware of what we are doing. And remember that when they talk about hazard, process, and equipment, it is in the human being that does the array. It is the human being that does the hazard identification. It is the human being that does the inspection and equipment. Procedures are still being written by human beings and reviewed by human beings. Taking trainings like this doesn't make you a subject matter of all, but it's just to throw you, to give you an insight of what is there in the bigger process, that you should go for further learning, consult people like our able presenter today, that if you are challenged, reach out to him. He'll be willing to assist you. Please, Dan, let us do the question and answer in an orderly manner. People raise up their hands. You acknowledge as usual, and we take it up from there.
Okay.
So I hope that is okay with you, presenter.
Yes, it's okay with me.
Thank you, sir.
Okay. We have Engineer Andrew Abanum. Go ahead with your question.
All right. Good evening, ladies and gentlemen. Thank you very much, James. The presentation was quite concise and insightful. Not really like a question, but rather a little contribution to the subject matter. From your presentation, it came out clear the barriers that needs to be in place for a safe operation. And as you rightly pointed out, that the human barrier seems to be the most important, because the human executes and also ensures that the other barriers are in place. With respect to risk assessments and the other procedural controls or barriers that you have, is also important for professionals, safety professionals and engineers to know that these barriers, reviewing these barriers at intervals is also critical to safe operations. For example, if we do have a risk assessment for as a mitigation for a condition, it is expected that the risk assessment has a duration in which it has to be reviewed whether it is still valid or it needs to be improved upon. So the barriers that we have, regular reviews of those barriers is also critical to safe operations. And when after that is done as well, it should be communicated to the all work parties that are expected to use that document. So communication of these barriers is really, really important with respect to the safe operations. all the barriers that has been mentioned so far, you talked about training, very important and very critical. And with that training, people become more competent, and that serves as a tool combining other barriers to make the operation safe. So when we mention, like I said earlier, things like risk assessments, like hazards, things like hazards, these are tools that also require regular reviews. For example, a risk assessment will have could be in a year after. If the situation still exists, it's expected that the risk assessment be reviewed, whether it is still robust and adequate, bearing in mind the current scenario on which that risk assessment has been raised. So that is my little contribution to the subject. Once again, I want to thank you, James, for bringing this presentation to the House. It's really enlightening, and I believe I've been able to gain something to add to my knowledge. Yeah, thank you very much.
You're welcome. Thank you. I totally agree with you. If you remember, one of the measures I put in place, the second one was regular reviews. And if you even look at the slide where I talked about barriers in general, you will see communication, you will see issues like handovers also being mentioned as barriers. So the idea of this presentation is to give us a broad and holistic view of what barriers are, because we are actually the professionals, the custodians in charge of barriers. We should be able to identify them and be able to evaluate them for their efficiency and their adequacy. Thank you very much.
Okay, thank you, presenter. We have the next person is Anthony Kwamize. So go ahead with your question.
Okay. Good afternoon, everybody. And good afternoon, sir, for your wonderful presentation. Very insightful, short, precise, but to the point. It's just a short one. You know, when we go for operations in the oil and gas industry, most times when you go to the field, management will always come on board, tell you more about operational excellence, you know, the importance, why we must keep our heads up and everything, do things to the latter, but on their own part, like you said about the latent failure. How come on their own part, they don't follow operational excellence to the latter? Why is it always so?
Okay, thank you for that question. You know, when we look at our HSE management system, leadership commitment is always first and key. Yeah. And wherever leadership commitment is lacking, the whole system starts to struggle. However, as somebody who has also been in the field, I realize that when people are put to the spot to make a decision, a clear cut on safety, they find it difficult to choose against it. It may be easy for them when they are carrying out the job to circumvent, but if you ask them on the spot, should we carry out risk assessment or not, they will not say no. You understand what I'm trying to say? So in most cases, one of the major advice I would like to give professionals is that try as much as possible to be proactive. Most of the time, time factor is what affects operations. When you need to get a job delivered and you feel, oh, if I go through this route, it may delay operations. Yeah. If you can, as a professional, give time ahead. Let them know, oh, look, this job we're going to do now, let's start doing the risk assessment now. This project we're planning for next week. Let's do the project, the risk assessment now, so that you can put those things in place early enough. But if at the time they are executing is when we now we can't do this job, but we have not carried out risk assessment, there's always going to be some pushback. But when you have good leadership commitment, they will step back and realize that, look, safety should take priority. But when you don't have that in place, then you need to up your game by being more proactive. But it is very difficult in most cases when you have an adequate barrier to put up for people, for anybody to deny whether that is right or wrong. I don't know if I've been able to answer your question.
Yeah. To a large extent, you actually did. Like where I'm concerned about more of those the management, top management. You know, they have a way of doing their things at times. The times they push for production more than any other thing.
I'll quickly tell you a story. When I was working on the at Ebok field at the time, we were going to do a welding operation on our FSO, and it was essential we carry out that job, but there were a lot of risk involved in carrying out that job. I was a safety man on site at the time, and I wrote to the management, and nobody responded. Even my manager did not respond. Nobody responded. The reason was because, yes, the job needs to be done. Nobody could say, no, don't do the job. At the same time, they were not sure whether there will not be an incident and who will carry the buck. Who will have said, oh, I was the one that said they should do the job. So because I was the man on site, I took the bull by the horn and I spoke with the FOS, I mean, the OIM on board, that I will personally supervise this job. We need to put 1, 2, 3 in place. And I wrote back to my management that we are going to go ahead with this job, having put this and this and this and this in place, and I'll personally supervise it. Nobody wrote back. Nobody acknowledged my mail. We carried out the operation. We carried out the operation successfully, and that was it. Secretly, managers came later to thank me for the initiatives and all that, but that is how it works sometimes. People want to cover their heads and all that. So, but in a case where I also know that this job cannot be carried out safely because certain things have not been put in place, even if management is putting pressure, I would definitely write my own points too and take my stand on the issue.
Beautiful.
Okay, thank you very much. Let's take the next person, Emmanuel Okudo. So you can unmute yourself and then ask your question.
All right, good evening, everyone. First, I want to thank the ESCOs of presentation. Mine is just a little contribution and 2 things I'm going to talk about. One is what Kwame they just asked now. Just to say that it's quite important. Some of this barrier, if you identify in terms of your risk assessment, talking about concepts of projects, then in terms of the front-end engineering, if you can do your barrier analysis and get this thing done, especially in terms of process control, you are halfway in terms of preventing incident or avoiding what we call unplanned shutdown or operations disruption. But when you don't get it right at the design phase, it becomes very difficult at some point in time because some of these barriers might involve shutting down and also installing some of these barriers. Then quickly, you know, barriers are divided basically into passive and passive, which is mitigating and preventive. Why I made this comment just this afternoon, someone called me. I handled a section with them some close to a year ago. And I told them they use a gas generator. And I told them before the generator, you need to have a suction port because of condensate. Otherwise, in the future, you might have condensate and that will damage your generator. They called me this afternoon. This is close to a year. And they are saying, oh, please, we will need you because our generator is malfunctioning. We have a lot of condensate, which is liquid. That was supposed to be a barrier from preventing damage and shutdown, which is the filter or a knockout port. Even I told them, even when you put filter, the condensate, depending on the rate of generation of that condensate, it might overwhelm the filter. So you have the people barrier, which James mentioned, that we incessantly go there and do drain off. And remember, When those people keep on doing this thing more frequently than they ought to do it, then fatigue creeps in. Then before you know, they will relax, and that will happen. Then lastly, barriers in terms of process automation. When you look at the API 14C, it mentions two critical areas, monitoring and preventing. And that is why in design is essential. Like James said, you don't need to mix these barriers. That's why we have what we call the fire and gas process control system, and we also have the shutdown system, talking about your cause and effect matrix now. In the design, you don't mix this together. Talking to what James talked about, independency, okay? It is separated. You don't mix fire and gas and process control shutdown. You have to separate them so that each of them, in terms of functionality, they will not function. Then lastly is the availability of all the barriers. What do we mean by availability engineering? Not just to have them physically, but to have them physically and for them barriers physically and to perform on demand. Basically, it has to do with maintenance, which has to do with the performance standard. And how do we achieve this maintenance? What James talked about, the people in charge, the maintenance guys, they need to ensure their preventive maintenance in terms of their process control, monitoring and reporting, corrective maintenance. All these things need to be in place for us to ensure the integrity and functionality of our barrier. Thanks so much.
Thank you so much, Mr. Okudo. There's one question here in the chat that said, if barriers should fail, leading to the top event, what are the recovery measures? This is from Mr. Festus. Okay, a quick response. You know, one other word for barrier that we are probably more conversant with is the word control. When you're doing risk assessment, you talk about controls in place and further controls recommended. Remember that we said both barriers for preventive and mitigating, they're all barriers, they're all controls. So even when you anticipate the possibility of having a top event, you need to anticipate what barriers should be in place to mitigate that top event. For instance, we do not want fire. We ensure that we keep the three elements of fire out of contact in our processes and our plants. However, because the risk of fire may still be present, we put other mitigating factors like having your fire gas alarm systems, having your sprinklers or your washdown systems, having your FM20 systems and fire extinguishers and fire hydrants, etc. in place. These are also barriers, but these barriers are mitigative. So you always need to look at both sides of the bow tie of what can lead to a top event and what can reduce the consequence of a top event. So I hope that was able to answer your question.
Yes, our presenter, thank you very much. I will not be able to go further than this. Hand over now to the coordinator.
Well, thank you, Mr. James, for a wonderful presentation. For benefit of lack of time, like I had said, this is quite an introduction into the world of barrier safety system, model system. We cannot all resolve it here once and for all. I will encourage that you join other oil and gas meetings for any other question that is left, and I assure you that justice will be done with it. But I want you to leave this session with one thing in mind. It is all about people. Because for anything to, when we talk about safe system, it starts with the process, the procedure, and the people. The people is a safeguard, the greatest safeguard we have in any system. In terms of an incident, the process fails, the procedure fails, who gets the harm is still the people. So the bottom line of it is that be trained and retrain and be at the top of your game. My parting word is this, that people make this mistake, that when it is not safe, it is not safe. As kind of trying to override management, we have process and procedures in safety. Arrays are being done, risks are being signed off according to the risk category. What can be eliminated, what can be controlled, what should be lived with is left to management prerogative. Yours is that please do not just jump into conclusion. As a growing engineer, as a great safety professional, over the time, with the help of James, with the help of current president, and even engineer Emmanuel, you grow in the profession and know why some of these decisions are being taken. Thank you very much. Thank you for joining this particular session, and we hope to see you all in the second session that is almost rolling immediately. I don't know if the president has anything to say, but I would just recommend that we just have a 2-minute break after her remarks before the next presenter comes in. Thank you very much. President, anything for us? Dan, line up the next person for 5 o'clock, and we can all have a 3-minute leg stretch that will be seated for reasonable time now, and 5, the next presentation should start. Thank you very much. Thank you, Mr. James.
Yeah, the president's hand is up. I don't know. Let her
go ahead. She has the overruling power.
Yeah, I was muted and I couldn't unmute myself. Thank you very much, presenter, and all those that made a wonderful contribution towards this topic. We all learned, and I know that a lot of us will come back when we have inquiries. I want to thank Mr. James. It was wonderful. I want to thank Mr. Abano and Mr. Okudo for their useful contributions towards this topic. I would want us to start like almost immediately while we're taking the recess. Let the secretary read the biography of is it the secretary or the chair? I don't know if the chairman education committee is available. If he is, he can take the bio of the next presenter while we start off immediately. Thank you.
Mr. Okando, so it's over to you.
Is he in the house?
Yes, yes.
Are you ready for that, Mr. Okando? He was supposed to read for James, but he didn't sign in early. Are you ready for his bow? Okay. I think let me go ahead with the bow. Are you, media, am I being heard?
Yes, very well. Go ahead.
Loud and clear.
Okay. Good evening, everyone. Our next presenter is a person of Engineer Johnson, NTEMUSE. I'm so sorry if I could not pronounce the surname very well. He's going to be presenting to us today process engineering flow scheme. And Mr. Johnson is a BSc holder in electrical engineering from the University of Ibadan. He had his postgraduate diploma in business management and leadership at the University of Cambridge, Wales, United Kingdom. He's a fellow of the Nigerian Institute of Electrical and Electronics Engineering and a member of Institute of Engineering and Technology in United Kingdom. Currently, he's the head of process control and automation for Shell Nigerian Limited. We present to you our presenter today. Thank you very much, Engineer Johnson, for volunteering to take us for this section. Thank you, sir.
Yeah, good evening. Good evening, all. Just to confirm that I'm being heard.
Yes, you are, sir. Good evening.
Yeah, thank you. I want to first, of course, thank the president and the ESCO and those who have made this possible. It's my extreme privilege and pleasure to be here. I'll do my best. So I'll try to also I want to also thank the previous speaker. Very good job. I probably completely align with what he has said. So this evening, my primary discipline is automation, control automation. So I'm talking about process. So I do a disclaimer now in case there are process engineers who know more than me in the house. Do pardon any error I'll make. Thank you. So let's go on. I think I have the slides not with me. I guess somebody's going to run that for me. I'm not sure I'm supposed to run the slides. So are the slides up? Sorry.
Did you submit the slides for presentation?
Oh, I did. Okay, so I did. So I thought to
okay,
present
I don't.
it.
Maybe he will be. He would think you would have told him he should share. I don't know, Engineer Okando. Engineer Okando, can you share his slide? Is it with you so you can share? I don't know why he's not. He's in the line, but I'm not hearing anything from him.
Okay, so let me need to check my system there.
Mr. Johnson, if you can share your screen.
Okay,
and
okay, I need to check my. So let me try to open up my.
Can you hear me? Can you hear me? Can you hear?
Yeah, Dr. Okando, we're hearing you now.
Can you hear me? I've been trying to reach out. I submitted the slide to Mr. Bankole.
Yes,
Mr. Bankole, are you in the house?
Yes, I'm in the house. I will just send it to the secretary now.
Sorry. Okay, I'll be attempting to open mine. Don't worry. I'll be trying to open if I can. Then
Mr. Bankole, you have this.
Yes, I have the slide.
Oh.
Okay, so
Please, Chairman Education Committee, please moving forward, always tell your presenters they will be the one to share. And if they are not familiar with it, have that conception, send it to the second time.
Okay, so let me see whether let me see if I'm able to.
Okay, I think I've sent the slides to the
What
secretary.
I would say, if you have your notes, you can go on while the media chair sends it to the secretary to get it all sorted.
Okay, okay. So so the presentation, as has been mentioned, is on process flow scheme and process engineering flow scheme, and the essence of this objective actually is to familiarize us with how this is developed and the importance of the process engineering flow scheme, as well as the application in projects and in the operate phase, of a facility. The process engineering flow scheme actually it's foundational. It's one of the foundational drawings you have in engineering for any project you need to produce. Okay, I think I can see the slides now. So that's the outline we'll run through. We can go to the next slide. Okay, so the objective, as I said, it's to really familiarize us. Some of us probably are already familiar with this, but also a few things around process engineering flow scheme and the application for projects and for assets, and generally, I mean, practically it's used for everything. And we're going to see that when we run through the presentation. Go to the next slide. So process engineering process flow scheme. Now, this is basically a high level drawing that is first produced after the process engineer. So the key discipline here, you want to develop a facility. Let's take an oil and gas facility or a factory, want to produce biscuit or whatever. Process engineer sits down and it's an agreement. We want to produce so much volume and so much rate, and block diagrams are developed. When these block diagrams are developed, they are put into a scheme, and that scheme would have major equipment, and there's what you call the material balance sheet. This essentially a sheet that contains the processes, the flow rates, for instance, temperatures at different points in the facility. At different point in the facility, you have all of this. But the process flow scheme is a high level, so it doesn't contain so much details. You see major equipment there. You see if you have different modes of operation, maybe you have single train running, double train running, you have steady state mode, dynamic mode, all kind of mode, you present it in different PFSs. Otherwise, you just have a simple PFS. If you have multiple equipment, you don't show it in the PFS, you just show one, but then you indicate that it's more than one. So in this, if it's a pump, you show just one pump times maybe 5, just to make it simple. Let's go to the next so that I can have the graphical display of the next slide. Now, so this is an example of a PFS, for instance. So is this simple? And on top there, what you have on top there is talking about the different kind of processes and their process that their dimensions. So for instance, if you look at, for instance, where the red arrow is, that actually is not the material balance sheet data, but it's the data from it. But if you come down and look at, for each of the lines, you see different diamonds. On those diamonds, they're actually called streams. And those streams indicate what process data you have there. So for instance, you can have a particular point in the facility where the temperature is high. Maybe it could be 100 degrees. And then by the time you flow through a cooler, heat and material balance indicates all of that. So the process engineer should have sat down with other disciplines, control, mechanical, electrical, maybe you have heaters there, turbines. You will look at all of that and say for each part of this facility, this is the status of the process parameters. This is the pressure at this point. This is the flow at this point. This is the temperature at this point. By the time it transits through a vessel, for instance, or through a compressor or through a pump, of course, that changes. So at some other point, again, you see another diamond that tells you at this point, this is the material status. This is the, and also, it also includes the pipings. Maybe the rating of that piping has changed from maybe 3 bar to 10 bar. So across the flow, the scheme, you have that material, and heat, the balancing. You want to show that across the board. So what you are seeing in front of you is a typical PFS. Let's go to another one. I mean, similar as well. But there again, you see that the details are not too. By the time you go to the PEFS, meanwhile, this is also called the process flow diagram. For there are different balances that are used. Call it PFS or process flow diagram. Again, the same thing. Now, a typical, this will have a grid. So you see the numbering. That numbering helps you to, to locate, where particular items are in terms of description. Let's go to the next. So after you have the process engineering flow scheme. Now, process engineering flow scheme is also called the piping and instrument diagram, the P&ID. Now, this represents the process, more detailed, schematic, pictorial, graphical, more detailed, and tells you the processes and gives you the details. So in this case now, as different from the PFS, you start seeing dimensions. Now, they're not to scale. They're not to scale, but you start seeing things like, for instance, if you have a vessel there, we tell you what the material of that vessel is. Is it stainless steel? Is it carbon steel? We tell you the temperature, the maximum operating pressure of that vessel. Tell the working pressure. We'll tell you the temperature of that vessel. We'll tell you, so you have those details, extra details. Then you tell you a lot about instrumentation. What kind of instrument do you have on that vessel or on that piping? Do you have, a relief valve on that vessel? Do you have a pressure control valve? Do you have a pressure shutdown transmitter? How is it installed? It will tell you all those details. So it tell you what kind of valves you have. Are they ball valves? Are they globe valves? Are they closed? Are they normally closed? Are they normally open? These are the kind of details you start seeing in the process engineering flow scheme or the piping and instrument diagram. You have legends, you have notes. Now, legends, so for every PEF, full dossier of a PEF, the front page is, we give you all the symbols, the symbols of the vessels, whatever is represented in that PEFs should be, in the symbol, more like a legend that has all the symbols, so it's something you could easily read, but sometimes, of course, you need to have the experience, but sometimes something you could easily read if you take your time to really go through the symbols very well. Now, let's go to the next typical PEFs, now, so if you look at the typical now, you see here, you see more details. Here you see the line numbers. So for the piping, the key thing you're going to see on the piping. So for every pipe, every line you see, it will have a series of number. Now that series of number has a meaning. So when we go down a bit, we're going to, I'm going to try to explain a few things about that. But so each of the line we have a number series which tells you things around the size of that line, the service is doing, the rating, the answer rating of that line. That is what pressure can it take, and all of that. So then you're going to see instrumentation. You're going to see, like in this particular case, for instance, you see a set of pumps there. Now, so you don't see those set of pumps, both the suction part, the discharge part, and and how it transits. And you see the arrows also showing the direction of where the flow is. So when you look at the end of the PEFs, you see where is the flow coming from and where is the flow going to. So when you see at the end of, the entry point, the end point, you see the description. So it tells you where is the next page of this. Now, if you also look at the bottom of the description, you see revision. So each of these have revision. I'm going to explain that later in terms of, is it for feed? Is it in the front end design stage? Has it been reviewed? Has it been reviewed? So you have the arrow 1, arrow 2, and when is it transiting to detailed design and to construction and all that. I will explain that. But these are things you see on the PEF. Let's go down a bit. I think again, yeah, similar again, detailed description. Now you see a vessel there. So that cylindrical horizontal vessel is a vessel. It could be vertical, it could be horizontal, and then on top of that, what you see on top there is a legend describing that vessel, as I explained before. So you see this. So on top of the vessel, you see the detailed description of that vessel. What is it? What is the the size of that vessel? What's the service? What's the pressure rating and all that? If you go to the next slide, let's skip to the next. Let's leave the third one. Let's go to the next one. Okay, now, so what goes into developing a PEF or PFS? I mentioned earlier the heat and material balance. So the process engineers essentially do that. It tells you the process streams across the facility, from the inlet, because as you go through inlets, for instance, if I take the oil and gas, for instance, from the well, you have very high pressures coming from the well. And then by the time you get through the manifold into the facility, the pressure start dropping. You could have control valves that step down the pressure, and then it goes into a vessel, a high pressure vessel that can absorb that high pressure from the well, steps it down, drop the liquid, and then goes to the next stage. So at these different stages, there's a change in in the process parameters. There's a change in pressure. There could be change in temperature. It could remain the same. You have change, of course. Flow rate could change as well. You could have, so all of these are indicated across the facility. Then you have the process control scheme. So these are the kind of scheme you want to use to control your process. For those of us who are familiar with automation, you could have split range, you could have override control, you could have simple control, you could have multiple control, cascade control. So these schemes are agreed between the process engineering and the instrumentation automation field. They agree what kind of scheme you want to use to control your process. Then you have a control narrative, process control narrative. It describes, the scheme. So for instance, you could be saying that when the level in the vessel rises up, then the level control valve should open and dump the liquid to another vessel or to a closed drain or whatever. So you do a description. So that narrative contains all of that. You also have the safeguarding memorandum, very important for designing your cause and effects and your trips, which usually sits on top of your control. You have philosophies, valving philosophy. How do you want to do your valve placement? Do you want to have valves having bypass, and all of that? Then tagging. So mechanical guys are involved in that. How do you tag your valves? That's your manual valve in this case. Then you have instrument tagging. How do you want to tag your instruments? Vendor information. If you're in detailed design, you then need to get information from your vendor to confirm some things. Relief valve sizing, operating philosophy. How do you want to operate? What mode do you want to operate? Is it the two trains you run at the same time? You have single train operation? All those things are things that are inputs you get to develop the PEF. The shutdown hierarchies, OSD, operational shutdown, emergency shutdown. How many levels of OSD do you want to have? Do you want to have OSD 1, OSD 2, OSD 3, and all of those kind of hierarchy of shutdown. So these are, amongst many, these are some of the key inputs that go into developing a PFS or PEFS. Now, talking about symbols, these symbols are essentially based on ANSI and ISA standards, and they are not to scale, as I said before. So your PEFs and P&ID, the drawings there are not to scale. So I'm going to talk about complementary drawings that helps you to put everything together. So it's a drawing that can be used for many things, but when you start going to construction, you need to have other complementary drawings, which I'm going to show. Okay, let's go to symbols now. So of course, I won't be able to exhaust all the symbols, but as I said, when you go to a P&ID or a PEF, the front page, the cover page, will actually have a legend that tells you, because they are bespoke, per PEF. You have those symbols that will help you to understand that PEF. So, so as I said before, you have the line number. So for every piping you see within the PEF, they have different, they'll be labeled. And if you look at that label, typically you see, like this case, you have 3NL 12. So if you look at this, it tells the first thing you see there actually, which is very important, is the size. The size, 3 inch, 3 inch, imperial 3 inch. And then you go further down, the service, the next number you see, dash, the service, is it liquid, is it gas? You see that as well labeled there. Then you see the other lines that follow, So the first line is like for the facility. So facilities can be numbered uniquely. So if it's a unit, that unit, for instance, if unit 21, unit 31, so those units, then you have the rating. That's another thing you need to So that rating is very important. When you go after like the A11A, the SA there is talking about the ANSI rating. So like if it's 150 pounds, you're going to have it as 1. If it's 300 pounds, maybe as 3. 150 pounds can do up to like 20 bar, 120 bar. 300 pounds can go up to like 49 bar, and then 600 pounds up to 900 pounds. Actually, there's a chart that you ANSI chart you can use to, depending on the temperature of the piping, what pressure it can hold. So let's go to the next slide. Now, so naturally, as an automation person, I'll be a bit biased there, so I'll try to run through most of the instrument symbols a bit. Mechanical symbols, I consider them to be straightforward. So you see the pump, you see the exchanger, you see the condenser, you see the vessels. But for the valves, the controller, because if you look at the typical PEFS, 60% of what you see are instrumentation, the valves, the control scheme. So this is a typical, signature of the valves. You see the different kind of valves, the gate valve, the ball valves, screw valves, and all of that. So you go to the next slide as well. You see automated valve. Next slide, you can roll up a bit. Thank you. So you have the self-actuating valves, then you have also you have the valves with labels, FO. FO means fail open, fail close. It can be either you see the FO there, or you see it indicated with the arrow, showing that this actually means that when the valve fails, it fails to those positions, and then you also have the fail to last position. And then you have the fail to last drift open or drift close. Actually, this has to do with the flow regime. So you could have flow with certain kind of characteristics and pressure that may cause the valve to fail towards opening. So you need to indicate that kind. So let's go. You have the metering, the flow meter types, whether they are turbine types or magnetic type. Let's go down. Then you have this. Let's go. You have the spectacle blinds, you have the spades, and also all these are symbols that will be the legend we describe to you, but these are just typical. I'm trying to just run through this. And then also you see instrumentations that have these indications, whether they are localized. So when you see it without any, usually when you see it like this without any line across them, it means they are localized. You can read them locally. So like a gauge, for instance. So a gauge will be indicated like this because you see the gauge in the field. So let's go down. If you then go to other ones that have the line across, it means they are also instruments, but they are not accessible to the operator. The diamond shape is usually for shutdown. So when you say diamond shape in that, and that shutdown, okay, when I go there, I'll explain the symbols for shutdown, like a Z and all of that. Let's go down. Let's run through this. I think the material will be shared, I suppose, so that we can have time to, it can be a reference for us. Let's go down to, okay. So let's go down.
But you saw it shaking before.
Okay. So you have line symbols. So when you see, this is also important, there are different signal types. When you see a straight line, it's just a simple process connection. But when you see, the dash, you see that you could be pneumatic signals, that's air signals. You could have electrical signals, you could have hydraulic signals. These are very common in whether oil and gas or even other industry. You can have different type of signal types. You have software signal, data signal. So let's go to other symbols. Thank you. Okay, let's go down. Let's go down. Okay. So now, again, so this, so when you see a typical PEF, you see the way the instruments are explained. So for instance, let me take, in my industry, oil and gas. Key parameters we run with are pressure, flow, level, temperature, key, and the other, a few other ones, like density and co. Now, when you see the LCA or LICA, now the first letter you see describes the core parameter. So if you see P, for instance, it's talking about pressure. You see L, it's talking about level. And then the next one is a condition. So if you see like LI, it tells you level indicator. Or LC, it tells you level control. And then you see alarm. So this is just trying to explain to us the different configurations you could see, you know, when you see this, when you see them lined up in your in the PEFS. So let's go now. So this is what I was trying to explain, you know. So you see here the PT there, pressure transmitter. You see the PIC, pressure indicator controller, and you see the signal type, air, pneumatic signal. So and you see the valve there is fail open valve, you know, pressure valve. So these are typical, and the loop number, when you see PT 103, PV 103, PIC 103, it means that control loop is control loop 103. So you're going to see 103 in a PEF, you're going to see 104, you're going to see 105. And so that tells you, in case you are troubleshooting, you know where the issue is. You know, so it gives you a unique description of that loop. So each loop has a unique loop number. So that's typically what you can see in a PEF. So let's go. Okay. Let's go to the next one. Okay. Okay, thanks. So let's go the next one. So this is similar to what I've explained. Now, so try to talk about revision. So when you go to your PEFs, you have different revisions. So this generally tells you when you initiate your first drawing, typically the revision number is revision 01, RO1. Then you could then have a peer review. Maybe you initiate, maybe process engineers initiate it, you know, with the automation engineers. And then after that, you want every discipline to look at it. And you have peer review, maybe with even colleagues from other departments and all that. You could rev it after review, and you have additional things to include in that drawing. You rev it up to the next revision level. Then you could issue that for a CL assessment, for HAZOP, for other reviews. And if those reviews come back with inputs, and you have to, you know, revise and include those inputs, you rev it up to RO3, and until you, by the time you are done and you say, okay, this is now ready for detailed design, you want to move it up, you can then issue it as approved for design. So it's now, it's no longer a feed, it's done with the feed, you want to move it on to detailed design. And then detailed design, you do DO1, DO2, and then if you now agree that that is okay for construction, you now rev it up to CO1. So that is now means it's approved for, or we call it AFC, but typically what you see in the drawing is CO1. And then when it goes to execution, then you rev it up as maybe you do your construction, and you have, usually during construction, you could have field changes, approved field changes where changes are approved within the project. They usually will have that management of change process within the project. And when you are done with your construction, then you stamp it as built. And that's what you hand over for operation. And of course, during operation, as you work with the drawing, you mark them up. And periodically, of course, marked up drawings are supposed to be signed off, and then they are usable, of course, with management of change. And whenever you periodically, like where I work, what we do is that every other period, 6 monthly, 1 yearly, we then redraft that drawing, you know, with all the marks up, and then we reissue it again to operations. So PEFs have a lot of application. So I cannot be exhaustive in what I will say, but PEFs have a lot of application. Your PEF, you know, can help you, like your feed, you do your feed, your PEF can help you for pre-contract, you know, you can use it to, you know, as a pre-contract, you know, document where you can use it to do initial cost estimates, because it shows you all your major equipment. You can use it to develop specification for pre-contract, for tendering, the initial tendering ITT. You could do your hack. You know, hack is area classification. So the electrical guys, you know, this is where you look at different zones of a facility, and then also helps you to agree what kind of, you know, equipment you want to put there. It's very like explosion proof equipment. How do you agree with them? Zone 0, zone 1, zone 2. And piping layouts, material takeoff, the MTO. So all of this, the PEFS can help you to do that. And of course, for training the staff, both engineering and operational staff, you can use this. Let's go to the next one. And then other applications for process safety review for HAZOP, as we've mentioned before, you need the PEFS. In fact, key document for HAZOP, you know, with all the methodologies you want to use for safety instrumented function assessment, the SEAL assessment or process hazard assessment. For layout position analysis, when you want to do that, you need for risk assessments, as we've been told before. For instance, you know, investigation, to develop your HMI graphics. So when you go to, you want to develop for your control room, operator stations, to develop that graphics, you need the PEFS, complete, you know, PEFS. For commissioning and startup, when you want to systemize your facility for startup reasons, for commissioning reasons, you use the PEFS to, you know, segregate your facility. So, okay, I want to start, I want to commission this section first, and then move to that section. You need the PEF, you need to mark up the PEF. And then for operation, life cycle operation of the asset. Let's run, I think we are getting towards. So there, as I mentioned before, you have complementary drawings that are needed for you to work with your PEF for construction. So you have what we call the hookup drawings. So this one essentially tells you how do you install your instruments. Let's move on. So it will tell you how to install your instruments, your gauges, your control valve. You have the general arrangement drawings. General arrangement drawings actually, that's the next slide. General arrangement drawings actually tells you how the plan view of your facility. How are the facility arranged? As I told you, the PEF is not to scale. So the GA will give you the placement, because the PEF will not tell you the placement of your equipment. You know, so but the GA will tell you this is where the heater is, this is where the generator is, this is where the vessel is. And so that's a drawing that is key. You have the 3D model as well. So this is reviewed during the project. The 3D model of your facility, you know, it's something that's also you need it as well. You know, let's go down to the next slide. So you have a typical 3D model. So these are a typical 3D model of your facility. So as this being constructed, your contractor, if it's an EPC, for instance, you can do a 30% model review where you look at how they've done so far, and then when you are going towards the end, you get a 90% model review where you now look at, okay, this is what we're going to, you know. Let's go to the next one. Let's go. I think no, next one. So isometric drawings are very important. Mechanical guys will tell us this. Let's go down. So the isometric drawing. This also tells you the elevations of your drawing, all the slopings and how these are installed. So the isometric drawings are also very important for your construction. So these are all drawings that complement the PEF. Whereas the PEF will be like the model-based drawing, but for you to move into construction, you know, you need all these other drawings, you know. Let's go on. So I think we are almost wrapping up now. So typical, so again, as I said, for graphics, you need your PEF. So this is a typical graphics in a control system. And this is developed using the PEF. It will not be as detailed as a PEF, but the PEF, you usually make this a bit simple so that the operator will not be confused, you know, but you use the PEF as a base drawing to develop your graphics. Let's go to the next one. I think, yeah, the next, yeah. So these are another typical graphics as well. This is what the control room operator will see. But these are all developed with the PEF. So it tells us if you make a mistake in the PEF, for instance, you also make a mistake in the graphics and all of that. And that's why when you update your PEFs, you need to freeze it at a point so that when you are developing things like the graphics, you are not confusing the operator. So let's go to the next, I think. Okay, so in conclusion, I've had to rush a bit and maybe, you know, I couldn't drill down on them more than I could now because of our time. But essentially, the PFS and PEFS are foundational, you know, drawings in engineering. And they present the entire process graphically. And, you know, and they feed into other drawings that can help us to achieve many things. So in terms of reference, so I would encourage us, there are a lot of resource online. Let's go to the next slide. There are a lot of resource online that can be quite handy for us, you know, to do. And I'll also be available even after now. If you want to get my contact and you want to reach me, I'll be disposed to do that for those in this association. So there are references, so piping mantra, ANSI standard, piping official. These are all. If you Google this, you get more detail on all of this. So I think this is where I'll conclude. Thank you for having me, and thank you for your time.
Thank you, Engineer Johnson, for that presentation. Mr. President, you can go ahead.
Okay. Mr. Johnson, thank you so much for this presentation. I'm sure you broke it down. For those of us in the house that are not really know what process safety is all about, your presentation had broken it down for their understanding. It was simple, it was straightforward, and very explanatory. We are very grateful. Thank you, sir. Thank you.
Welcome, ma. Thank you for the
I don't know if the coordinator is around to coordinate the sections for questions and answers. Okay, if he's not there, Secretary, please, can you present his certificate first before contributions? For those that have contributions to add up, please you raise your hand and the Secretary will coordinate after the presentation. And if you have your questions, you could either put it in on the chat or raise your hands to answer. While he will be there, he's there. We have a lot, I can say a lot of process safety professionals in the house that can as well support this presentation and throw more light to it. Thank you, everyone. Secretary, over to you.
Okay, thank you. On behalf of ASSP Nigerian chapter, we present this certificate to you in recognition of this of volunteering as a speaker on processing engineering flow scheme during the Knowledge Sharing Series 3 of July 25th, 2020. So we appreciate that very cogent presentation we have from you. Thank you very much, sir. So please accept this certificate. We are going to send it via email at the end of this session.
Thank you very much. Much appreciated. Thanks for the recognition and thanks for the opportunity. Very, very much appreciated. Really.
Thank you, sir.
Thank you, sir, for volunteering.
So we'll go into the question and answer session. So the first person is Engineer Andrew Abanum. So go ahead, please.
All right, good evening once more, everyone. I really want to especially say a big thank you to the presenter, Engineer Johnson. I want to say that within a short time that was given, he was able to, you know, take us through a full course. And it's really interesting. I've been so refreshed by the session. And I want to also say that I know most of the persons that are on this call, they may not be engineering biased, but as a safety professional, this subject is very key And if you must ground yourself in process safety, you must be well acquainted with drawings. As a safety professional as well, you must understand drawings, even though you are not engineering bias. So it is with this foundation that we've all got today. If you are working at a site, I would like to encourage you to get close to someone who understands drawing, and I can guarantee you, you are going to be very vast when process safety is being discussed. So once more, I want to thank Engineer Johnson, but I will just quickly, for the benefit of others on the call, to ask Engineer Johnson to probably talk a little more about markup drawings. Yeah, we know when the drawing is completed, handed over to the asset, he mentioned something like markup drawings. I want to ask him to explain a little bit so that for the benefit of our vast audience. Thank you.
Yeah, thank you very much. Good question, and a question that is quite troubling, because what happens is there's what we call management of change, and I'm sure if any of us are familiar with that term, it's an engineering term. It happens in every probably business, but now when a drawing has been stamped as built, that's the bus stop for that drawing. But because a plant will run for 25 years, 30 years, 100 years. I mean, I've seen a plant in Holland, Rotterdam, that has been there for more than 100 years as the time I said the place. Now, this plant will not be static. There'll be things will go wrong. I mean, engineers will do their best. A valve will get bad. You need to do a small bypass of a pipeline in the course of the life cycle of that plant. Now, when you do that, if you don't update the drawing, then as safety professional, you are creating room for potential incidents. And it's very common where you go to a facility, you see a drawing, and you want to run to the side. By the way, I forgot to mention that if you want to learn about any facility, please do always ask for the PEFS when you get to that facility. You know, spend one day, take the operator if it's chance, then run you through it, run through the lines, then you know the facility very well. Now, so when you look at the drawing and it doesn't align with what's on ground, very common, that usually will cause an issue. So markup actually just means that whenever you are doing a change or you want to do a change, I want to add a new 3-inch line. I want to tee off. This is a 6-inch line. I want to tee off a 3-inch line from that and put a VAR. Why? Because we have a new process we want to commission, or there's a new generator we have brought, and we need to get gas from the main line. We want to tee off gas and supply that new generator, a gas generator. What you should do by law and by engineering practice, you should go through a management of change. So you take your drawing, you mark it up. Somebody who is authorized, use a red, which I call a red mark, you use a red pen, best practice. You mark up, you add that line, you draw that 3-inch line, you draw it through a valve, probably through whatever, a scrubber, whatever, to the generator. And then when you get to that generator, you draw the generator as well, because that's a new add-on. When you do all of that, somebody authorized signs it off that you have marked up that drawing. You go for a management of change. It is challenged. The risk is assessed. Of course, you do risk assessment, then you go to management of change. When that's approved, then that drawing becomes the new drawing for that facility. So it's now a marked up drawing for that facility. Now, you don't, when you do that, because of reason of cost, you don't just go to a draftman to draft it. You can do that if you have the money, that's good, that's best practice. Otherwise, you can wait for some period. But your new drawing is now not that as built, is the marked up as built. That's now your new official drawing. So if you are training people, if you want to do a graphics design for your control system, you now must go with that marked up drawing. That's now the new official drawing for that facility. As changes are going on, you use that drawing, you keep marking it up. After a period, maybe after 6 months, you have so many red lines on your drawing, it's not best. You then get a draftman It's not the best. Get the draftsman to now update the drawing as a whole. They now draft it, and they will now put a date. So on the legend part of that, on the bottom of that, on the bottom of the PEF, there's where you see people writing the revision, the dates, and who signed it off, who checked it, who reviewed it, who checked it, who approved it. That is done. So a new date is stamped on that drawing to tell that this drawing was done 25th of July, 2020. That becomes your new drawing. It's not uncommon in facilities to see drawings with different dates. And that leads to different, I mean, I'm talking from experience. Somebody does the construction or build something on the old drawing. And when he goes for construction on site, he sees another thing there. Maybe the place he thought was free is no longer free. And so it's a good area where as safety professionals, when you go to a facility, always ask for the latest drawing or the latest marked up drawing. Confirm that that is what is latest, and then start from there for anything you want to do for them.
Okay, thank you, sir. Don't know. Do we have any other questions from participants? You can
Yes,
raise
I
your
think
hand. Okay, we have
Mr.
Okay, no, Mr. Akiemi Johnson.
Yes. Good evening, everyone.
Let's take Okeogene first.
Okay.
Evening.
Okay.
Thank you very much, sir, for the wonderful presentation. I'm actually upcoming in the instrumentation design field, so I'm really glad for this opportunity to listen to a professional with vast experience. So I would like you to throw more light, please, on safety instrumented function assessment study. You talked about what the PEFs can be used for.
Yeah.
So I would like to ask, is the PEF, some people call it P and ID.
Yes,
is that acceptable? Yeah, P and ID.
Yeah, that's
Is that enough to carry it? Is that document alone enough to carry out a safety instrumented function assessment study?
No, it is not. Thanks for asking this question. You know, one thing that I missed out in terms of time. Now, you also have what you call UEFS, Utility Engineering Flow Scheme. So for big facilities where you have, so it will include, we include things like the instrument air drawing. It will include things like if you have other, utilities, fire, water, potable water drawing, all those things. So you have that. Then there's another major drawing which comes to Okeogene's point, question around, we call it PSFS. So I don't know what the industry calls it, but where I work, that's what we call it. But it's actually, you call it Process Safeguarding Flow Scheme. Now, it's just like the PEF, but in this time around, it only contains short-down drawings. So it only contains drawings that have to do with trips. So really, safety instrument function, Okeogene, is actually trips. Whatever trips your facility, is a safety instrumented function. There are other names for it. They call it IPF as well, instrumented protective function. So it could be called instrumented protective function, safety instrumented function, and then you can call it trip. So the normal name is trip. When you say this thing trip my facility, it's actually the safety function that tripped it. Now, if you want to do a SIF study, assessment study, now the essence of a assessment study is what you call, want to extract. Sorry, are you still hearing me?
Yes, sir.
Can you hear me? Sorry.
Yes, they're hearing you, sir.
Okay, so I don't go to too much of that, but the safety study is what gives you seal level for your trips. So each trip, each SIF, safety function, have different level of trips. I mean, different level of robustness. So, and that robustness is established as per the SIL level. So you're able to have SIL 1, SIL 2, SIL 3. Now, because of time, I'm able to do that detail of what those means. But those things just establish the robustness of those, SIL 3 being the highest robust, that is the one that has the highest integrity, because SIL means safety integrity level, the highest integrity. So depending on what you want to protect and the consequence of a failure of a trip, then the robustness is established. Now, so you need the PFs, you need the PSFS, you need the safeguarding memorandum. You need sometimes you need the process control narrative. So those are key documentations. Of course, you need the HAZOP report. So the HAZOP report, because the safety surveillance function assessment comes after the HAZOP. So the HAZOP report is helpful because the HAZOP is the one that recommended, in principle, the HAZOP either take credit for existing trips or recommends you to add a new trip. So those are key drawings. So good question. You need your PEFS, you need your HAZOP report, you need your PSFS, process safeguarding flow scheme, you need your process safeguarding memorandum, and you need your process control narrative. And then you need to also have the right team to do it. The team has to have process engineers, operations engineers, of course, automation engineers, routine equipment engineer if you are going to deal with turbines, if you're talking about turbines, and then of course static equipment engineer if you need, you're talking about vessels, and electrical if you're talking about heaters and all that. So yeah, so those are really what you need for safety assessment study.
Okay, thank you, sir. Let's take Mr. Akiemi Johnson. Can go ahead with your questions.
Oh, Mr. Johnson.
Well done, good evening.
Well done, good evening, sir.
My own is Akiemi Johnson. Your own starts with Johnson.
Yes, sir. I know, sir. Well done, sir.
All right, well done.
Yes, sir.
See, when you talked about the P&ID, you know,
yes, sir.
I just want to add that it's somehow a live document for the safe operation of any facility. Working in a process plant, and there was a time that they wanted to walk inside the vessel, and you know, the operators, the maintenance people, in short, let me say the multidisciplinary team on site, you know, they were finding it difficult to really find the point of isolation, you know, where they can carry out positive isolation to the vessel. Indeed. So that they can safely carry out the maintenance work. What rescued that day was the P&ID. But quite unfortunately, you discover that a lot of facilities don't upgrade their P&ID or as built.
Yes, indeed. Sometimes not.
And so that gap primarily exists with most process facilities.
Yeah, indeed.
You get it?
Yeah,
yes, and then when audits are carried out, you know, you discover that they begin to get a lot of NCs.
Yeah,
you know, so
yeah.
Just to be an advice that for any processing facility, if you're in doubt on where to isolate to carry out maintenance job inside any vessel, you know, the P&ID is becomes handy, you know, becomes very handy at that point.
Absolutely.
Thank you very much, and well done for the good presentation.
Thank you, sir. Thanks for the on point, sir. On point. Nothing to really add. Yeah, key.
Okay, thank you, sir. Let's take Mr. Emmanuel Okudo. Go ahead, sir.
Yeah, I want to before he asks his question, I want to thank Mr. Johnson for that contribution. But I want to ask, we've had cases where you go to the plant and then you find out that there's no P&ID document, either the documentation is missing or it's not available.
Or key parts are missing. Yeah.
Yes. So at that point, what do you do? We have one at the moment.
Scenario.
What? Okudo, yeah.
That's a nightmare scenario. Okay, I'll just say that's a nightmare scenario. When you don't have the drawing, if you can get consultant in to help you rebuild the drawing. But yes, so they can do that, but it costs you money. But you shouldn't run a facility without drawing. It's like running blind. Because like Mr. Akiemi just mentioned now, for everything you want to do, you want to isolate, you want to recommission, you want to restart, you want to do anything you want to do. Really, it's a model drawing. It's a model drawing. The P&ID.
Yeah.
It's a model drawing. So if you don't have it, even to train your operators will be a problem. You can hardly train your operators when they don't know what to do. Your maintenance staff will have issue. You bring an expatriate in to work for you. He wants the drawing. Without a drawing, so really it's almost impossible.
Handicap. Yes.
Yeah, you are really handicapped. So it's something we need to. Yeah, it's a running battle, but sometimes we might even have it. It's not up to date.
Yeah.
But it's worse when you don't have it at all.
Exactly.
Yeah. So it's key to have it. Yeah. It's absolutely key. There's no.
And that makes it difficult to do your management of change again. You know.
Oh yeah,
Exactly.
everything is frustrated. You can't do your hands up. You can't do your anything. You can't really do anything.
Yeah.
Tim, we're evolving.
Thank you.
Mr. Emmanuel, that is the last one we'll take, and then hand over to the coordinator.
All right, good evening. Once again, thank you, the ASSP ESCO. Engineer Johnson, a wonderful presentation from you. I'm really excited listening to you. I'll quickly make few contributions based on experiences. One, I need to quickly mention that for those of us that are safety professionals, it's quite important you know all these things, because that's the basics. And that is the reason why some of us are not involved in design review. And even when we attend hazard workshops, we are not effective in terms of contribution, because it looks like rocket science when they start mentioning all these terminologies. First, all HSC guys working in the plant, manufacturing plant, you need to know about it. Secondly, I also want to contribute to the question, Wata, she asked a question, two areas, approaches to determine your safety integrity function. One, when you finish your studies and all that, even before you commission your plant, you need to do functional testing of your equipment, okay? That is very key. Then in addition, there are two basic approaches. One is your layer of protection analysis, which have the input from the hazard, which Engineer Donsi talked about. Now, if you are using the layer of protection analysis to conduct your SIE, we need to be very thorough in terms of our safeguards, recommendations from the hazard. Having said that, there is still this other approach that has to do with the risk graph approach. That talks about using the facility cause and effect. I'm sure that should be the other name from what Engineer Johnson is talking about, that they call something safeguard memorandum, something in their own system. I think cause and effect that takes cognizance of the shutdown systems, and which is separated into process shutdown and also your facility.
Thank you. Cause and effect is important for this assessment.
Cause and effect. Okay. In addition, from experience, for those of us that you carry out scope of work that has to do with engineering and services, please, I want to beg us to always get in touch with the main people to provide the exact P&ID, okay, what is on ground. If it's not, we don't need to rush to do certain things. If it's very urgent, then you need to also urgently update it. Because I'll share two experiences, then I'll stop. My first experience when I carried out a fire water design verification review, I was working somewhere, it's an in-house study where I was given a lot of data, P&IDs and all that. I used that to do all my calculations and all that. But somehow I had to travel to the site, and I presented the P&ID to the operators. These are the main guys operating this facility. Looking through it, the first question, Oga, where did you get this drawing? All the equipment here, the pumps, we have changed them more than 5 years ago. I was just looking at them. So I had to start my calculation all over. So there is a disconnect between the guys in the field and the guys in the office. Oftentimes, if you need the right and correct information, you go to the field. Because there's no updating in terms of this PFS updating and revalidation, so that becomes an issue. The last one I will share with you was an ROBI I actually led in one of the offshore facility platform. I was running through the P&ID, tracing the lines. Along the line, I was lost because what I'm seeing in the P&ID are not exactly what I found here. I had to call the OIM, and at the point he was also lost. I was asking, this is your facility, you should take me through. And that's when they told me this is a very old drawing. Okay, can I have a new drawing? They said they don't have it, they are working on it. So when you don't have up-to-date information on your drawing, is going to affect your studies. Whatever studies you carry out, name it, is not going to give you a true reflection of the risks or the safety integrity level of your plan. So whatever the outcome of the drawing, it is like garbage in, garbage out. So it's quite important for us to have all this drawing. Once again, thank you, Engineer Johnson, for the wonderful presentation.
Thank you, Mr. Emmanuel. Okay, let's over to the coordinator, please.
Okay, we are 1 minute over 6. I know we have a time contract for 6, but then what needs to be done right. Thank you for everyone for staying this long with us. Thank you for the faith. Thank you for the belief in the society. I truly believe that together we'll create a better and safer future for Nigerians. My only remark is this, is that, like I had said, the safety professional is the safety profession is evolving, and we are almost like GP, general practitioners, and master of none. Ma and others have said it, that when the chips are down, zero in to subject matter experts for help. You may have the generic idea, but you still need more training, more hands-on, more exposure to raise that competency. I encourage as many as possible that whenever they have periodic hazard risk analysis for your facility, join. Part of it is always the P&ID reviews. When they have some startup and volunteer your time off and so on, just for the learning process, and you will truly appreciate today's session of knowledge sharing. I have learned a lot too. Some of the numbers, DC, RC, was confusing to me, irrespective of my 25 years in the field of safety. So please, I encourage you, go back, do more learning, do more reading. The association is there to help you. You can see what we are gaining now. This is just oil and gas. Tomorrow, it may be transport, and these things are interwoven. No knowledge is ever lost. Apply this knowledge in all that you do, both on and off the job. As a joker to all of you, the simple term that we all laugh about, we've had management of change, and MOC. MOC may be in engineering, it is there in administration, it's there in transport, you use it in managing changes. So please don't get confused. They are all related to one and the same purpose, how to manage change, like for like. So I wish all best of the rest of your evening as you recap or you reflect what you have learned. I don't know if President has anything for us, but please, the same number of people coming out here, I expect we give the next specialty the same audience, the same support like they've given unto us. And remember, it is not finished. The oil and gas will be trying to come up with our own local Nigerian side meetings where you can meet some of these presenters off meetings like this for question, and which you can bring. We will be bringing our networking back home, a little bit home. Thank you very much. Thank you for the opportunity to lead this session. Thank you, ESCO.
Thank you very much.
Thank you, everybody.
Thank you. Well, don't worry, do the final one on Thursday. Thank you, our presenters and everyone that had keyed into this section. We have all learned today, and I know that by the grace of God, as it grows up, we will learn more. I want to thank all that had shared their experience. I want to thank the coordinator for the month. But we still have one section, please. Normally, our sections comes in every Saturday, but we have a discussion session to round up this section for oil and gas, which is on Thursday 30th. Please join us. We will send the flyers out within a week, so that I can also share to your network as well. I want to thank you all, and I hope to see you in the next edition for Thursday. Thank you, and God bless.
Thank you. Bye-bye.
Yeah, thank you all. Thank you.
Thank you
very much.
Thank you. Bye. Thank you
Thank you
very
all.
much. Thank you.
Thank you very much. Great session. Bye.
Bye. Thank you all. Thank you.
Thank you very much. Thank you all. Bye.